More than 90% of carbon fibers are made from polyacrylonitrile, or PAN, a derivative of petroleum that is produced as follows. Crude oil is extracted from the ground and transported to an oil refinery. During refinement, about 2% of the oil is made into propylene, which becomes feedstock for a petrochemical plant. While processing at the petrochemical plant, propylene and ammonia are combined during an ammoxidation process. The result is the production of acrylonitrile, the monomer or base unit of PAN. The process moves to a polymerization stage during which the acrylonitrile is combined with catalysts and comonomers and reacted to produce PAN. The PAN passes through a drying step and is dissolved in a carrier solvent. It is then pumped and filtered. The PAN is extruded through a die into a solvent bath to form the filaments that appear here in fine strands. A filament cross-section can take on a variety of shapes. Textile-grade fibers, as shown here, are often kidney-shaped and highly porous. The filaments undergo repeated cycles of stretching and washing, during which the strands are banded together and the filaments become longer and thinner. As the solution is washed away and the filaments are stretched, the porous voids collapse, aligning molecular orientation to create a stronger fiber and the desired fiber diameter. The filaments continue through repeated steps of stretching and this time a boiling wash. The cross-section of the filament continues to hold its shape as the diameter collapses and it becomes less porous. Next, finishing oil is applied to protect the fibers and make them easier to handle. As illustrated here, the diameter is now even smaller and the porous nature of the filament has collapsed even more. The filament is then packaged, illustrated here by crimping and baling.